In the last few videos, we showed how common forms of 4D geometry can actually represent the motion of 3D forms instead of some higher, abstract spatial axis still taught about today. What about more uncommon 4D forms, though? Take this shape, for example. This is a 4D shape based on the same pattern as the earlier examples. It is composed of two cubes with all vertices connected by new lines, but those lines are not straight, but curved. What could that represent? It represents rotational motion of a cube, which draws a very different pattern from the other hypercube examples. Again, just like the others, there is an initial state, an end state, and the paths of motion in between, composing an object of true 4D geometry, its 3D history of motion through space and time. How about a sphere? What does it look like in the fourth dimension? Unlike a square and a cube, a circle and a sphere have no vertices to sprout new edges from. A circle is defined as all points in a plane lying at equal distance from a center. To move from a circle to a sphere, we do not stack or join circles. That would only produce a cylinder. Instead, we extend the same definition into three dimensions, the set of all points lying at equal distance from a center in every direction at once. But without new 4D edges, how do we represent a 4D sphere through a 3D spacetime map, like the tesseract and pentatope? A sphere expanding and contracting leaves no trail of edges, but if we simply notate the initial state as T1 and the end state as T2, we can still animate the motion that takes place in between. Keeping both states as a representation of the 4D event, we are simply left with an outer shell, an inner sphere, and the region in between, much like the tesseract was an outer cube and an inner cube with space in between. A sphere rotating presents a new problem. Without the wireframe, this sphere's rotation is not easily noticeable. So how can we represent it through 4D geometry? In this case, adding an artificial reference like the wireframes is required. So, what is a more simplistic way to create a 3D spacetime map to represent this 4D event? Instead of a complete wireframe, we can just mark one point on a sphere, and as the sphere rotates, that one point will move and trace out a path. That path is just one of its 4D edges as it moves through spacetime. We can do the same for an expanding and contracting sphere. A single line edge would be drawn between the outer sphere and the inner sphere, wherever the artificial mark is placed.